Good evening, students. Myself Dr.A.Vaniprabha, Associate Professor, EC Department, working in SNS College of Engineering. Continuation of our lecture series on signals and systems. Today we are going to discuss about energy and power signals. So far we have discussed on continuous time and discrete time signal, even and odd signal, periodic and aperiodic signal. Today's lecture is on energy and power signal. So any type of signal can be classified as either energy signal or power signal based on the answer or the condition what we arrive, right? Okay, we have already discussed about energy and power signals in the previous class. Today, we are going to evidence through an example whether the given signal is energy signal or power signal. So as to decide a signal is energy signal, we shall calculate using the mathematical formula E of t is equal to integral minus t2 plus t x square of t dt. Right. So the final answer is greater than 0 and less than infinite, then the given signal is an energy signal. Similarly, the same applies for a power signal also. If the answer of the power value is greater than 0 and less than infinity, the given signal is decided to be a power signal, right? So any periodic signal which is of finite duration is nothing but a energy signal, and also any signal uh, of finite duration which is non-periodic in nature is termed as energy signal, and any signal which is periodic and infinite in nature is decided to be a power signal. So these are the hints to remember before we calculate through the formula and get the answer. On seeing the signal itself, we shall have a prediction on the type of the signal. Then we shall verify through the mathematical formula, right? So this is the graphical representation of a signal, right? The energy signal, the first signal is the power signal since it is periodic and infinite in nature. And the second signal is an energy signal. This is the formula to find the energy and power signals in continuous time. Energy is equal to minus infinite to plus infinite x square of t dt, whereas power is equal to limit t tends to infinite 1 by 2t integral minus infinite to plus infinite x square of t dt. Whereas for discrete time signal, it is in terms of summation x of x square of n. Whereas for p, limit n tends to infinite 1 by 2n plus 1 summation n is equal to 1 to n x square of n. The same condition, energy must be greater than 0 or less than infinity for a signal to be an energy signal, whereas the power must be greater than 0 and less than infinity for a signal to be a power signal. Comparison between power and energy signal. So the formula itself varies for both energy and power signal. Both the condition is similar for both the power and energy. It should be greater than 0 and less than infinity, whereas the formula varies. And all the periodic signals or power signals, whereas the non-periodic signals or energy signals, and the signal is given for your understanding. See, the first signal is a sine wave and another one is a discrete time signal. Both are periodic in nature, and it is infinite, right? Therefore, the given signal is a power signal. And the second uh, column represents the energy signal. This is a unit step signal which is of finite in nature but periodic. So this is the energy signal. The important points to remember, I discussed now, no? The hints to remember whether the given signal is energy or power just before calculating. We can observe the signal carefully. If it is periodic and infinite in nature, then we can conclude the given signal is a power signal. And if it is a periodic and finite duration, then it is an energy signal. That's what it is shown in this previous table. The first column represents the power signal, the second column represents the energy signal, Under this first column, see the first signal is a sine wave which is periodic, we all know, and it is of infinite duration, right? Therefore it is a power signal, whereas in the second column it is a finite signal and periodic in nature. This is an energy signal. So before, if the given signal is in graphical in nature, you please observe the signal first and try to understand whether it is periodic or non-periodic or finite or infinite. Then we can easily identify the answer and can ensure or verify whether the answer is correct or not using the formula. So just examine this problem. Find whether the following signal is a power signal or energy signal. Determine power and energy if of the signals. F of t is equal to 5 cos 17 pi t plus pi by 4 plus 2 sin 19 pi t plus pi by 3. Rewrite the question. X of t is equal to 5 cos 17 pi t plus pi by 4 plus 2 sin 19 pi t plus pi by 3. And already we have referred the coefficient of t is omega. Right. Or we can write straight away f1 is equal to 17 by 2. This we have obtained through the formula 2 pi f is equal to 17 pi. Right. 2 pi f is equal to 17 pi. Pi gets cancelled and f is equal to 17 by 2. Since we have two terms here, the first term is f1 and the second term is f2. Therefore, f1 is equal to 17 by 2 and similarly f2 is equal to 19 by 2 hertz. And from this we can identify the fundamental time period, which is the reciprocal of f1 and f2. t1 is equal to 2 by 17 and t2 is equal to 2 by 19 second. Since t1 and t2 is equal to, the ratio of t1 and t2 is equal to 2 by 17 by 2 by 19. The 2 gets cancelled and 19 by 7 is a rational number. It is a fractional number. Therefore, the given signal is periodic. And from the hint that all the periodic signals are power in nature, we'll have this in mind, but we have to verify through calculation, right? Okay. For the so as to substitute the fundamental time period in the equation, we should have a single value. So the period is t is equal to 17 t1, which is equal to 19 t2. Therefore, it is equal to 2 second. Therefore, the periodicity or the fundamental time period of the given signal is 2. Therefore, power is equal to, from the formula, 1 by t integral 0 to t x square of t dt. Therefore, replace or substitute 2 for t, which is equal to 1 by 2 integral 0 to 2 x square of t dt. So, substitute the x of t given in the sum, 5 cos 17 pi t plus pi by 4 plus 2 sin 19 pi by t plus pi by 3 the whole square dt. And next step, you substitute as usual what we proceed in mathematics. So based on the formula, cos square theta is equal to 1 plus cos 2 theta by 2 and sin square theta is equal to 1 minus cos 2 theta by 2. We can rewrite the previous step in such a way. Right, t is equal to 1 by 2 integral as usual. The coefficient are written as like that, and expand cos square term and sin square term and substitute the value of t as 2. And finally, here the fifth and integration will become non-zero. Therefore, the rest of the terms are evaluated with the help of the function, and finally the answer is found to be 29 by 2, which is nothing but a rational number or an integer. Therefore, the given signal shall be named as a power signal. And we already knew that all the periodic signals are power signal. Even then, we are trying to verify through mathematical calculations. Therefore, the given signal, the value what we obtained is finite and also non-zero. As it stick on with the formula, P must be greater than 0 and less than infinity. It's 29 by 2 is a fraction which is greater than 0 obviously, and it is also less than infinity. Therefore, the given signal is a power signal. Right? So hope you understood this simple problem. We'll practice a few problems in the class. Thank you for patience listening, students. Thank you very much.